Hello everyone. Today we're going to discuss the last module of partial differential equation. Partial differential equations. As in this heading, you have two things. One is the partial and another one is the differential equations. As you have studied the number of different types of differential equations, that is an ordinary differential equations. And you know how to find the solution, how to form a differential equation, and each and every methods of the ordinary differential equations. Now we're going to join us, instead of ordinary, we're going to join it's a partial. And you know the something about the partial differentiation. And you will combine both the things, partial and differentiation and differential equations. We say partial differential equations. Let us derive the definition. An equation contains partial derivatives is called partial differential equation, or you can also say an equation involving the partial derivatives of one or more variables of a function is called as partial differential equation. Let us take some simple examples. Let us say it is dou z by dou x plus z is equal to 0, or it may have it is a second order dou z by dou x square plus this is dou z by dou y, which is equal to some variable x. Like this, you can write the number of differential equations. Now, in this partial differential equation chapter, we're going to learn from the scratch, that is the formation of differential equation and solutions of different partial differential equation by using the different methods. The first thing, we take the formation. When we say it is a formation, we have two different processes for a formation of PDE. When we say it is a formation of PDE, we'll have the two different ways you can form a differential equation, that is elimination of arbitrary constants, and the other one is elimination of arbitrary functions. Let us take a first one, the elimination of arbitrary constants. This process is same as the formation of the ordinary differential equation. In the ordinary differential equation, we're going to eliminate the constants, or we're going to substitute the values of the constants in terms of derivatives. Let us have a simple example in the partial derivatives. We'll use the same way here also, that is z is equal to x plus a into y plus b. Form the partial differential equation of the equation z is equal to x plus a into y plus b. To form this, here a and b are the constants. That too is an arbitrary constant. We have to eliminate these two constants in terms of derivatives, or by using the partial derivatives. And here, when you are using the partial derivatives, let us take dou z by dou x. That is, differentiate this equation partially with respect to x. When you are differentiating partially with respect to x, then all other variables as a constant, therefore it is y plus b into this, both are constants. This is x plus a, the differentiation of x is 1 and a is 0, therefore this is nothing but y plus b. The same way here, it is dou z by dou y, which is equal to, this is x plus a. By using these results, you can write the differential equation from the given equation. Z is equal to, instead of substituting for a, I will substitute for x plus a. That is, x plus a is nothing but, it is dou z by dou y into y plus b is nothing but, it is dou z by dou x. This is our partial differential equation after elimination of the arbitrary constants. Now, this equation can also be represented in terms of the notations. That is, normally we denote the partial derivatives in terms of the symbols, alphabets. That is, p is equal to dou z by dou x, q is equal to dou z by dou y, and r is equal to dou square z by dou x square, and s is equal to dou square z by dou x into dou y, and t will be equal to dou square z by dou y square. The normal notations for the partial derivatives first order and the second order is, it's a p, q, r, s and t. And by using these notations, we can rewrite this equation as z is equal to, for dou z by dou y, it will be q and this is p. This is the partial differential equation after elimination of arbitrary constants. Now let us take another simple example here. The second one here. Form the partial differential equation of the equation z is equal to xy plus y into square root of x square minus a square plus b. Here also we have two constants a and b. You have to eliminate in terms of the derivatives, or in the equation you have to eliminate it. The same way here also we're going to differentiate it with respect to x, dou z by dou x. When you are differentiating with respect to x, y and all other terms as a constant, therefore it is a y, plus here y is a constant into the differentiation of this one is 1 divided by 2 into square root of x square minus a square into 2 into x, that's an inner differentiation, plus the differentiation of b will be equal to 0. Now see that thus 2 and 2 will get cancelled. Therefore, I can write this one as dou z by dou x will be equal to y plus x into y divided by square root of x square minus a square, and we call it as, this is an equation number 1. As if there is no proper guidelines to form a partial derivatives or a partial differential equation by elimination of arbitrary constants, but you have to use the valid mathematical operations and the differentiations to eliminate this arbitrary constants which are exist in the given equation. Now let us differentiate with respect to y. It's a dou z by dou y, which is equal to, when you are differentiating with respect to y, x is a constant and differentiation of y is 1, plus for this differentiation of y is 1, but sure it is the entire thing is a constant, we'll keep it as it is because it is a multiplication. This is a x square minus a square, plus this will be a 0. This is a 0. From this equation, I can write it in terms of, this is a x square minus a square, can also be written as, this is dou z by dou y minus x. Just I have transferred this x to this side and I have written as the value of the square root of x square minus a square. And we call this as equation number 2. Now by substituting 2 in 1, this is just a value of The value of this is a x square minus a square under the square root can be substituted here. Then the entire equation become a partial differential equation without any arbitrary constants. Therefore, by substituting 2 in 1, 2 in 1, we have this is dou z by dou x, which is equal to, I can say here y plus xy whole divided by, for this you can write it this one, it is dou z by dou y minus x. This is what we have taken from the second equation, and we have substituted. Now just simplify or rewrite this equation. Dou z by dou x, y I will transfer it to this side, y, which is equal to xy divided by, this is dou z by dou y minus x. And just cross multiply it. Here it is dou z by dou x minus y into dou z by dou y minus x, which is equal to x into y. The same equation can be written in terms of the symbols. Here it is p minus y into q minus x, which is nothing but x into y. Now see that this is a partial differential equation with respect to a given function, after elimination of arbitrary constant. This is the way you can eliminate the arbitrary constants by using the partial derivatives, and we can form the partial differential equations. And here, as I have told you earlier, there is no proper step-by-step process. You have to use only your techniques to eliminate the arbitrary constants in terms of derivatives. The same way as we have provided you a question bank, which is for a partial differential equation. In this differential equation question bank, you can solve the same way. Here it is. The question numbers I will give you here. Question numbers is 1. The next is I'll give you the question numbers. It's 2, 6, 7, 8, 9, 11, and 12. By seeing this video, learn how to form a partial differential equation after elimination of arbitrary constants. The same way, you take these questions and solve in the same method. And you try to submit these question answers when you are coming to, when you come for the college. This is the first lecture of a partial differential equation. Any doubts, you can revert in your WhatsApp groups or contact any teachers of the Department of Mathematics. Thank you.